Hello and welcome back to compiler programming. In the last video we made work argument parsing, at least for one argument, and before we do the two ones we need to figure out how we're actually going to use them. So I think I'm going to combine multiple argument parsing with a simple expression parsing, and for today what I want to do is make a plus function work. So we'll say that it's going to be a plus. It's like this, and actually I might even remove all of these checks because we already have it for the functions above and they're not checking much at this particular moment. So I think that would be okay like this. We now have function definition, this is fine, and we need to change function type, so it will be a 64 to x64. In particular, we'll say 40 and 2, and it will be 42. So the function will be x s64, y s64, and it will do x plus y, right? So this is what we want to be doing today. Now, let's try to figure out what we need to make that happen. Let's run the tests, see it explode, and know what we need to do afterwards. Okay, so apparently there was an error even before that. So what is the problem here? Okay, that needs to be called arrow. Okay, let's rerun the test. And expression of more than one item with broken English are not implemented. Okay, so this means we need to do something about this stuff. And this is where the tricky part will begin, but also the one that I slightly explained here. We will do part of this stuff. We will not do the whole thing, but eventually we'll need to do it. So what are we going to do about that? Well, I guess I want to create something that will be called parse expression. It will accept body, and or since we make everybody accept parser state, let's make that accept parser state. So the root will be body. So we pass on that thing, and I think we also make it accept a program. Okay, so that's what we want to do. And now body result is just going to be whatever the parse expression is going to return to us. Okay. Oops. So that's good. We can take this stuff and actually even this helper things and move it somewhere over here. Okay. Time def struct. Actually, we don't need that. We can right away return a value. And we don't call it parse, we call it token match. So let's continue token match expression. So this is what is happening here. We're passing this stuff around. That sounds good. And what else do we need to do? Well, I guess that is fine. Okay. So state root children. We'll eventually get rid of it, but first I want to make sure that we have everything as it was working, and after that we will make new stuff work. So that's good. Okay. Body result is fine. Instead of body result, we just do return. And then we do return. And we have assert, and then we probably will have to do return 0. Okay. So for now, I'll just change it like so. And we also need to pass on a scope, which is fine, because we parse expression in a particular scope. And in this case, it will be a function scope. Good, let's try the test. We still have a new failing test, but besides that, everything should be fine. It looks like it is, and we can continue with our work. Okay, so what do we need to do now? Well, the first thing is, let's reiterate what is actually supposed to happen. We just have right now x plus y, right? And we just have, we already sort of know what to do about integer or id, but we don't know anything about plus. And with stuff like plus, the idea is that, so we have this state passed to us, right? This is the state. And I think for partial expression, we might actually want to change slightly how we represent this stuff. But maybe we can actually we can probably survive as is at the moment. So x plus y, right? We first try to match this stuff, and only then we try to match everything else. And in particular, this integer and id, it is sort of already working correctly in a sense that we are only interested in doing anything with it if it is a singular thing. However, when we match plus, we only then need to try to figure out what is on the left side and on the right side. So this function will most likely be recursive, and this is just the nature of parsing expressions. And we need to do our to make it work. So the idea is that we will probably actually use the raw version of token match, as we don't want to match from the beginning, but rather we are only interested in plus. Like, we could match to like whatever, right? We could say that there needs to be something, but it's pretty useless work. So better would be to try to just match it directly. So how would that work? That would be something like token state 1, and then we try to match this stuff. So it is an operator, and king, and this would be star plus, and slice literal in this case will be plus. Okay, so we are trying to see if the first one is plus. If it is, then we are good. If it is not, then so we basically let me think how I want to tackle this. Basically, plus, if we are not matching it, then we are expecting that there is only one child. The reason I'm not so sure is because I'm not sure when we want to make a jump to a more complicated version of this, but I guess it might make sense to do it right away. And what I mean by a more complicated version is that we will be gradually replacing tokens with something else. So we will have this stuff here where we have different token types, and I want to introduce new token type which will be called value, and that token type will just be a value pointer and say value. Actually, that should only exist in that might be a union instead of this stuff. So let's put a union around here. Like, we shouldn't have this stuff. It shouldn't be possible to have value and children at the same time. Okay. What do we need to do? The idea is that we'll change this function here. We have this root, right? And it has children. We will go through each child. So let's do that. Go through each child and say U64 x or I is 0, I is less than children. Pretty standard loop, and we are trying to match something in there and replace it with something else. For now, let's even forget about the plus. I will even comment it out. And let's try to make just the single one work, but as a loop thing. So something is really not great here. I probably messed up all the way at the top. Okay, let's see what did I do wrong. And the problem is a semicolon here. Okay. We don't know what the root is. Now let's do it like this. But we might not even need this mature state. We might already replace it with something else. Okay, token type. That's fine. We can put value here. Okay, it's builds, but this is not doing what I wanted to be doing. Okay, so we go through this stuff, and essentially we do multiple passes in the order of precedence and try to match it there. So the way I guess it would look like is as follows. Well, I do want to at the top check if it is empty. That will just make things slightly easier. So we say return 0. Okay. Now we are sure that there is at least one. We can remove. We actually don't even support 0 children at the moment. Okay, that's interesting. I guess now we do. So that's good. And Okay, what's next? Next, we said we go through this stuff and we go in order and try to match things. Okay. So we can move this stuff here. Okay. But we don't want to return necessarily. We want to replace it with something else. So we had an array. Let's say we had an array. I'm not sure how to present like this probably. And that array had number 42, which is like a token. So int token 42. We want to make a pass through that array and replace it with value token, which is like this value of 42. So just like kind of turn tokens into something that we can actually use. Usually this is done in one pass in traditional parsers, but I want to make it a bit more dynamic, and this is why it's a bit confusing both for you and for me. But I think this will allow for nice dynamic behavior long term. So this is what I'm going for, but it might take a bit to get there. Okay, so we go through the stuff. If we find integer, we want to replace it. So what we are doing now is we are saying that tokens star results token is temp allocate token star result token is okay, this is what we call. So we say token star expr is star din array get state root children I. Okay. That's nice. We say that parent is expression parent. We don't really need it, I guess, but let's keep it for now. Source is express source. And then we say that value is like this, and type is token type value. Okay, and that is good. Here we are basically doing the same thing where we looked up var, so something like this, and we now are replacing some stuff in that array. So we're saying that dynamic array set I, and then it's gonna be a result token. Okay, and the same thing here. Okay, I need to say that it's a token. That's fine. Missing semicolon here. And we need to say to what we are actually setting. So we gonna do this stuff. Actually, it should be like this. Like so, and like so. Okay, that builds, but we are changing stuff inside of that array, but we are not actually doing anything useful. The idea of this whole setup is that in case we have more than one thing in the array, we will be collapsing or reducing that into one thing. So when we will get to plus, we also will turn it in, the result of it will turn into one value and replace all three values with one value. But for now, I just want to make the basics work. And for basics, what is supposed to happen is we need to assert that basically the same thing. So at the end, once we stopped reducing everything, collapsing it, we are supposed to be left with one thing. And that one thing is going to be the result of the expression. And we say like this, and we say token star result is the array length of what? Well, this is gonna be, actually, this is not length, this is get state root children 0, right? Because here we tested that length is 1, so it is safe for us to get the 0th element. We assert that result type is token type value, right? So we kind of evaluated the thing that we wanted, and we say return result result value. Okay, that sounds good to me. Let's check. This needs a star. Let's try to run the tests now and see if it makes sense. Okay, this works, but this is a simple case because we are already doing whatever we are doing. However, in reality, after we replaced basically we need to figure out when do we stop replacing stuff. And we stop replacing stuff as when there is nothing more to replace. So here's how it goes. We create a bool variable and say bool has like did replace, and we say by default is true, and we say while for yeah, I guess that is fine. So we say did replace and I here. Now we say did replace is false. And if we find something to replace, we say that we did indeed replace. So this is true, and this is true. I want to try to run it again, so I didn't mess it up for the edge case of one thing, and I didn't, so that's good. And now the next thing is we are actually right now exiting because we run to the end of the loop. So we just have one item and we get past it once we do this stuff. But what is actually supposed to happen is that if you replaced something, you need to start all over again, because you might be have a recursive pattern like in the case of plus, and you want to always be collapsing the first thing, at least as long as it's left associative. So like we will probably deal with associativity a bit later. For now, I'll just say that whenever you did some replacement, you want to collapse, you want to start from scratch. So we say I is 0. Okay. Actually, no, this is wrong. We want to say did replace. Yeah, the actual loop is a bit different. We don't want this condition here. We want to do it like this. And basically we probably want an outer loop. Let's try it like so. It's like this, and like this, and like this. Yeah. And we can even do it like this. So we do this. We start with false. And then while did replace. Okay, something like this, I guess. Okay. This needs to go outside. Let's try to run that again. Okay, actually this no longer. Well, here basically I need to do actually a break. Because I said did replace and I break, that means we go here, this goes from the top, we start here and we do it all over again. Let's see if that works. Okay, that does work. Now is the tricky part, and the tricky part is dealing with the plus and also dealing with precedence, because right now what happens is we actually we're just getting the first match, and we don't care that, for example, multiplication goes before addition, and maybe that's okay for now. Let me think for a second about this. I guess that's fine. Well, we can sort of easily simulate the precedence by just copy pasting this loop and saying that this stuff happens in a first pass and then plus happens afterwards. We could also do plus differently in a recursive way. And right now, on top of my head, I'm not sure which one would be better. I guess we'll just try to implement more and more features. And if we realize that things are not working the way we want them to work, well, I guess then that would be a good indicator for us that something is not okay. So let's say that if expression type is token type operator and expression source slice equal expression source slice literal plus, right? So this is a case of we found a plus, but now we need to figure out where that plus is, and there are a couple of conditions with that, right? The first thing is we need to say, actually we can probably do it like this. Token star left hand side, like this, I guess. Left hand side pointer, and we do dynamic array pick of the true children. Actually, we can do this. Just trying to think where would be better to do this check. The idea is that we found the plus, but we need to have left or right. And I can do it like this. I can say that I is more than 0, actually more than 0. And I plus 1 is less than dynamic array length. Right? Let me actually do it this way. I think the precedence should be fine, but I never really trust myself and the precedence, so I prefer to not debug this stuff for a while. So let's say states roots children. So if there is something before us and there is something after us, then we check if we are on a plus, and if we are, we can start doing some nice things. In particular, we can say that we have left hand side, which is dynamic array gets this I minus 1. We have right hand side, which is I plus 1, and we can start doing things. So by the time we get here, we expect that both left hand side and right hand side have been already reduced to like this stuff basically happened. So we don't expect to come across anything that is not a value. So let's assert that expectation and say that left hand side type is value and right hand side type is a value. Once we have that, we are ready to do stuff. And what we need to do is now a bit tricky. So it looks like we need to pass here not just scope, but also function builder, star builder, something like this. And we say that we want to have a plus. So we say value star result is plus of LHS value and RHS value. So left hand side and right hand side. Okay. We have result token, have this stuff, we have result, and this is where things will get a bit complicated, because now we had 3 items and we have replaced them with 1 item. Luckily though, I believe I do have a method in onArray that allows us to delete elements. So let's see if everything works correctly. Say dynamic array delete range state root children, and we have range u64. It starts at I and ends at I plus 2. So the way this works is this range is like not inclusive on the right side, and we want to delete till I plus 1. That means we are actually putting I plus 2 here. At least I believe that is the case. Okay, here we need some stars. And fix the arrow. Finally, here we need to pass in one more variable, which is builder. Okay, so that builds. Let's see what is going to happen. I do want to open the debugger right away because the function itself is not going to work anyway, because right now we are not parsing this stuff correctly. So I just want to see what is going to happen to our to the rest of the parsing, because it's kind of interesting to figure out. Okay, I want okay, let's do it this way. We pause here. Okay, let's go inside. Something really interesting here. We parse first argument, and then we go into here. It's return types, and this is the interesting part. So this is the body. Okay, we have more than one length. We start with replace false here. Go through here, we get the child. Child is an ID, so we will have an ID. We try to look up. We were successful with lookup, I think. Yeah, we have this register C, which means that we found the first argument. Everything is fine. We replaced it, we break, and we start again. We go through this. This is not an integer, this is not an ID anymore. Okay, this second thing is not an integer, not an ID, this is supposed to be a plus, right? This operator plus. Okay, so this is good. Next one is ID. We try to look up, and we have a big fat null because we didn't succeed at parsing arguments yet. But this is still gonna be fine here, so this will pass, that's okay. This will go, and go. And now we are trying to parse plus. This is never gonna be the first match. We are trying the second, we were able to succeed. We got the left-hand side, and left-hand side is fine. We got the right-hand side, but and even this is fine. But if we look at right-hand side value, it is null because that thing is null. So this is gonna explode probably over here. Yeah, cool. So at least we are on the right track, or something resembling the right track. Now what needs to happen is we need to do something about argument matching. And there are a few ways here as well how we can approach this. One way would be to say that something like let me think what I want to do here. So the basic idea is we have this pattern, right? We have x is s64, and then we have comma, and then we have this again. And we can have 0 or more things in that list. So we can basically be slightly dirty and try to split it on comma, kind of, like a standard string split, except we say, okay, we create fake tokens, or we take care of the tokens in the match argument, and we like try to see, okay, is there a comma there? And if there is a comma there, then we are successful. Which one do I want to go for? I guess let's try to do the matching of the comma here. So how would that look like? Token match argument. Okay, we have blah blah blah. This is fine. And okay, this might be a bit awkward to use, so we need another macro here that would be like maybe match, token match. Let's just do it manually first and then figure out what it will look like. So yeah, actually this is fine. So we just take this stuff here and put it here and say maybe match token ID args. Does this work like that? I hope it does. Well, let's see if it does. Okay, list builds. So I would say maybe token match of comma, and this will be now we need maybe a match operator, and it's fine. I'll just do it like this for now and then figure out how to do it later. Operator and slice is comma. Okay, so what do we do? Okay, if comma, and then not comma, pick index minus minus. So here's what I'm trying to do. This is a bit awkward, so I'm probably doing something not quite right, but it will do the job for now. And what I'm doing is, let's get back to this stuff. We are starting here. This is where our state is, right? So this is state. Starting from here, we have matched this thing. I try to match this comma. If I didn't match it, then I sort of roll back and I stay over here. And what I will do is I will just say, okay, now it is going to be the starting point of the new match, either after the comma or before the comma. And at the end, we can also assert that we have reached the end. It's not a very robust system, I'd say. So I need to think about it, but for now, this is fine. So I'm gonna say state, what's this called? Child index. Yeah. State child index is pick index. Yeah, something like that would be fine. Okay. Now we can try to do that again. We go inside. Oh. I think we need to rebuild it or something, because it was really unhappy with the what? Okay. No, very good. And we are throwing match argument, token pick match, read access violation. That's not good. Let's recheck the token pick implementation and do it like this. If, yeah, that's not how it's supposed to be. I guess I need to say token star star pick. If not pick, then return 0. Otherwise, return star pick. Okay. Is that any better? Looks like we are still very much crashing, but let's see how is it going. Okay, at least we are getting better. Okay, and let's see what happens when we go inside of here. So we go inside, we do this. Try matching. Pick index is 4, still 4, and we change the state to 4. Okay, that seems fine. We create result. Okay, but here we actually need to also loop. Where is this stuff? Yeah, so we say U64 previous child index is args state child index. So this is sort of a similar loop to what we have above for the expressions. Maybe at some point we'll be able to merge them together, but for now this is what needs to happen. So we do this and we say, actually this needs to be args. Prev child index is arg state child index, and we say while they are not the same. So we are checking again the same thing. We are checking, did we make any progress? Was this a successful match? Okay, if it was, then we do it again. And technically here, oops, here what we can do is we can say assert that args state child index is I'm missing a while here. This needs to be a dot, which means this needs to be a dot, and this needs to be a dot. So this assertion is basically, did we reach the end? Okay, let's see what happens when we try to run it now. And we have not reached the end. Well, we did in case of void, which makes sense, but we didn't do in other case. So let's try to see what's going on. So it looks like we have actually also been successful in the case of a single one. So it is only the multiple one where I'm not doing something right. So let's debug that. Okay. I will not go through the first one because I know it will match just fine, right? But I'm more interested is what happens to arg state. So right now, child index is 4, right? We do arg and we define, so that's good. They are not the same, so we go again. And now it is an interesting part where we go inside. We check that we have an ID, we have a colon, we have a ID again, we have a comma. So we don't have a comma because it's just 2 of them, so that's fine. And here it's wrong. So it is good to read your own code even when you're debugging. So what the issue is here, this is supposed to be plus equals. Okay, let's try that again and see what happens. Okay, well, that's better, I guess. And now we just ran into the same problem as we did last time. And look at that. That is really, really nice. So it looks like everything worked the first time, which is great. I'm not particularly happy with how this code is turning out, so I'm trying to, as I said before, to deviate from the standard parsing idiom. So don't look at this and see and think this is how it's supposed to be done. But I'm trying to make it so that we can eventually make these matches in dynamic and very easily add stuff to the parser. So that means that some things will not work out as good as they can on the first try. But I'm still very happy that we made some good progress. So now we are able to have multiple arguments and we can parse at least this stuff. Let's see if something crazy will work. I'm not certain it will without problems, but I want to try. So we want to try to do this. And we say 30 plus 10 plus 2, right? So this is a triple plus, which means we need more S64 here. Let's hope we have this function. We do? Well, let's see. Well, I guess I need to believe in myself some more because it totally worked like it expected. So that's great. That means that both parsing of multiple things is working as it should, and we can actually have as many pluses in there as we want to. Again, this whole thing here is slightly awkward and inefficient, but at least for now, it does what we want, which is great. So that will be it for today. Hopefully, see you next time.